Hi, today we are going to talk about binary trees. Binary tree is a data structure. In this data structure we have nodes and each node have a maximum of 2 children. For example, this node that has 1 has 2 children, number 7 and number 9. So this number 7 we call it as left child and number 9 is the right child. This node 1 is a special node and we say it is the root. And if the nodes has no children, we call this node as the leaf nodes. So for example, node 2, 5, 11 and 5 are called leaf nodes, while nodes 1 is called the root nodes. So the size of the tree is the number of the nodes in the tree. In this example, if we count the nodes, we will find that the number of nodes here is 9. So the size of this tree is 9. The height of the node is the length of the longest path to the leaf node. For example, the node 7, if I want to know what's the height of node 7, I will take longest path to the leaf. So I have 2 paths or 3 paths to the leaf, this path and this path and this path, but I will take the longest path. Let's say this path is the longest. So how many steps I do in this path? I do 2 steps. So the height is 7. The height of 7 is 2. The height of 6 is 1 because I can take 1 step to go to the farthest leaf. And the height of 5 is 0. The height of 1 is 1, 2, 3. So this is the longest path to the leaf. So this is the height of a specific node, but I can say also the height of the complete tree is equal to the height of the root node. So in this example, the height of this tree is 1, 2, 3. Okay. So now let's go to the implementation of binary trees so that we can understand the implementation of the binary tree. We create new project. Let us call it binary tree. So this project we will create, for this project we will create 3 classes. So it's a binary tree, it's here. So we have a class, this is the main class. We want to create a new class called the node class. So this is the node. So each node in the binary tree, it has 3 things. First, it has the data. Let's say it's of type object. And it has a node left. This is the left child, and it has also a node right. This is the right child of this node. So this node has 2 children and also it has data. And then we create new class with the name binary tree. Let's call it binary tree because we call it the other one class as a binary tree. Binary tree 1. So normally we should not call the project binary tree, and then we can call this one binary tree, but let's call it binary tree 1 to solve this issue. So in the binary tree, we need to have a special node called root. So we will have a root in the binary tree for sure, and the root have left child and right child and so on, and every left could have left and right. So we want to add two methods in this binary tree. So the first method, it's called the size, public void int size. So this size should return the size of the tree. So to define the size of the tree, let us return the size of the root node. So we will define another method, it's called size. It computes the size of a certain node. So for example, this size is take as input node n, and it should return the size of the tree that has a root n. Okay, but for the complete tree, if I return the size of the root, then this is the size of the complete tree. So now let's try to implement this method, size node n. If I have a node n and I want to know the size of the tree that has a root n, if n is null, this means like I don't have node n. So in this case, I should return 0, because then I don't have any nodes, even the root has no node. So else, otherwise, and here I will use recursion. Recursion is very powerful here. So if the root n of the node n is null, I will return 0. If it's not null, then I will return the size of the left plus the size of the right. So I will compute the size of the left node plus the size of the right node, and size of n dot right So I will compute the size of the left node and the size of the right node, it's dot, and then I will add 1 to this. Why I'm adding 1? Because I will count the root. So because I'm counting the root, it's 1 plus the size of the left part of the tree plus the size of the right part of the tree, and this is recursive. So this will compute the left part, this will compute the right part, and then I will just add 1 to this so that I can compute the size of the tree that has root n. So with this I compute the size. Now let me make a method that compute the height. Public int height for some node, let's call node n. I want to compute the height of the node n. If the node is null, if n is null, then I will return -1. Returning -1 means that this node does not exist, so it does not have a height. So I didn't return 0 because if the node has no children, then this node has height 0. But if there is no node, I should return -1 because there will be no height for node that does not exist. So else, if If the node n exists, then what's the height of the node n? It will be 1, return. It will be 1 plus math.max n, height, I'm using recursion, n dot left and height n dot right. So if this node is some node, it's not null, the height of this node is equal the maximum height of the children plus 1. So with this recursive formula, I can just compute the height. What if I want to compute the height of the tree? Public int height. So it does not take any input, it's just the height of the tree. I just return the height of the root because this root represents the tree. So in this case, I will return the height of the tree. Now let's go back to the main class. So I have a binary tree. It has two methods mainly, size, height. It's like size, we have two methods, size, and height, we have two methods, height. So I have 4 methods. Let's go to the binary tree and let's construct our binary tree. So binary tree 1 equals new binary tree 1. So we construct a binary tree. Is the name correct here? Okay. Just 1 minute. Cannot find the symbol. So we have a class binary tree. We should be able to create object. It's in the same package. So binary tree 1 equals to new binary tree 1. Still not happy. Okay, for some reason this does not work, but let me show you one example that I tried before. So here I create binary tree t equals to new binary tree, and I create node n1 equals to new node Ahmad, and I assign Ahmad to be the root of this node. So this node has a root Ahmad, and the left of the node Ahmad is Khalid, the right of the node Ahmad is Samir, and the left of the left, which is Khalid, is Hani, and the right of the left Khalid is Salim. So Khalid has 2 children, Hani and Salim. If I want to print the size of the tree, 1, 2, 3, 4, 5, I should get 5. If I want to print the height of the tree, I should get 2, because now I have Ahmad has Khalid, and Khalid has 2 children. So I have 2 levels, the length of the path from the tree, from the root to the leaves. So let us run the code, and then we get 5 is the size of the tree, and 2. So let's compute like the height of the root dot left. So t dot root dot left. So in this case, I'm asking about the height of Khalid. So Khalid only has 2 children. The children has no children, so the height should be 1. If we run the code, we will get a height as 1. If I add a new node, t dot root dot right, so I will add one child for Samir. Let me add left child. Muhammad. So in this case, I'm adding a new node and the number of nodes should increase to 6. Yes. So as exercise, we need to implement this binary tree, implement a binary tree including the size and the height methods, and then test the implementation by creating a tree. And we need as exercise to write a recursive method that prints all the node data. So in my example, I wanted to print all the names of the nodes that I have. So that's for today, and see you in the next video.